Hey kids! All right, we are into Module 3, and today we're going to be talking about Lesson 5, and we're doing subtraction with fractions. So the objective for today is to subtract fractions with unlike units, and then we'll create like units with equivalent fractions. So starting out, this is, again, information in the teacher's manual that I don't know if your teachers are going to go over with you, but these are practice problems to help you understand the concept. So if you had something like a group of mixed kids, some are boys, some are girls, and you have a set, if you want to take one out, you have to specify, well, I don't know what the unit or the label is. So you have to use a label or unit that applies. So changing boys and girls to students, then you have like units. So if you have 3 students minus 1 student, now I know I have 2 students left. So subtraction is about taking this whole, W-H-O-L-E, I've said that on other videos, the whole, and removing a part of it. And so draw this little picture so that you can have this visual, because what's left is going to be the answer. So in the teacher's edition, there are some practice problems to kind of help you see what's happening. And I really like to have a colored pen nearby so that I can really show what's happening with the subtraction. So if you take 1/2, you can see that previously I had half was drawn, and then 1/3, and again the horizontal lines, this was 1 out of the 3 parts. Make a picture so that you can remove like parts. So remember how to lay over each of the fraction models onto the other one. So you turn the thirds into halves, and then turn the halves into thirds, and what you end up with is sixths. Mathematically, it's 2 times 3 is 6. That's how you get those sixths on the bottom. And then you're going to change the numerator at the same rate that you're changing the denominator. So 2 times what is 6? 2 times 3 is 6. So 3 times the numerator would be 3, and then you have 3/6. Same thing over here. 3 times what makes 6? 3 times 2 is 6. Whenever you do that on the bottom, you do that on the top, so 1 times 2 is 2. Do your subtraction, and you end up with 1. So you have this picture of like parts, but what you've created, we don't have, it's not like addition where you're just putting everything together and counting the total number. This is the whole. This is essentially all you have. Now, if you know that you have to take away 2 of them, cross them out. And what you're left with is the answer. Okay? That's what these pictures or area models are all about. That's the first sample problem. The second one is 1/3 minus 1/4. And again, 1/3 was here, 1/4 was here. Lay over the fraction models onto the other piece. Turn this one into fourths and turn this one into thirds. And then again, 3 times 4 is 12. And so you have your 4/12 minus 3/12 equals 1/12. And so these are equivalent fractions to these, right above and below the model. And then you take these 3 and you remove them from the whole that you started with. This is the whole, W-H-O-L-E. That's what you start with. This is the whole, W-H-O-L-E. That's what you started with. So this over here, it's just to remind you that every fraction is actually a division problem, and anytime you feel like not seeing this number in fraction form, you can divide it. And so since now you know how to divide a small number by a large number, I did 1 divided by 12. I annexed the decimal and some zeros, and then I proceeded to divide. And so that's where I got 8 times 12, 96, subtract, get 4, bring down, divide, and then what you get is this repeating decimal. You'll always have 4 left over, and then you make a 40, but 40 is not evenly divisible by 12. That's where you get that 3, 3, 3 forever. This is the forever line. And so these are also going to equal a percent. Eventually we'll get to that. You shift the decimal 2 places and plop in that percent sign. That's a lesson for another day. On the top of the back, we have the last sample problem, and it's going to focus. There we go. 4/5 minus 2/3, so we don't have the ones on top anymore. So again, shading multiple pieces, and then 5 times 3 is the 15. You get that when you lay over the model from one to the other. And then you have equivalent fractions where you can subtract. And again, this one, you have 12, and you have to take away 10 of them. The only reason that we're creating this is to figure out how many to take away. And so I would take away 10 out of the 12, and I would be left with only 2. Okay, so that's what we're doing today in our books. So go ahead and get your Learn books, and we'll prepare to make a model. And keep that colored pen handy, or colored pencil, or crayon, or whatever you need to write with. So for the following problems, draw a picture using the rectangular fraction model and write the answer. Simplify if possible. I think it might be time to put up a video about the rules for simplification, but again, not right now. So first of all, I need to create the whole, W-H-O-L-E. I have 1/3, so I'm going to draw my, they call it a rectangle. It looks more like a square, but a square is a rectangle. We'll learn more about that later. And I'm going to take away 1/4, and these will be horizontal. Make your 4 sections and shade 1. But I can't take away when I don't have the same number of parts. This is a bigger piece. Thirds are bigger than fourths. I can't take a fourth away from here because these are not in fourths. I wouldn't know where to put it. So lay over the thirds here and do the fourths here. 1, 2, 3 lines makes 4 sections. And so now I have 12ths, all these little lines. Looks like in a little emoji thing. Okay, so 12ths minus 12ths. And again, how many do I have? So here I have 4 12ths, and here I have 3 12ths. So I've created equivalent fractions, and now I can subtract. So I need to take 3 away from my 4. So 1, 2, 3. This is just telling you how many to take away, and you end up with 1. Like that. Okay? And when we get to the point where we have to simplify, we'll start talking about some of the rules. So start out here with your model, 2/3 vertical first, and 2 are shaded. Taking away another model, and I have 1/2, so I'm going to take away 1/2. But I can't take away 1/2 when I don't have halves here. So I need to make an equivalent fraction, and 3 times 2 is 6, so if you lay over the fractional pieces, you see that you now have 6ths on both models. And I have 4 shaded here, and then I have 3 shaded here. And remembering how to do the cross canceling, or cross multiplying, that's going to give you the new numerator here. And this is going to give you the new numerator here. And so that's mathematically what's happening. You can look for those numbers to be related. 4 minus 3 is 1/6. And again, I'm taking 3 away. And then I'm just left with 1. Okay, so that's what's happening here. I know what's happening here. Okay, sorry. There it is, another song. 5/6. Okay, out of 6ths, I'm going to start with thirds on the left and thirds on the right. So if you cut it in half, make 3 here and 3 here, because 3 plus 3 is 6. Okay, so help yourself along as much as possible. And I need to shade 5 of them. I love that movie. It's so good. Moana, make way. Okay, and 1/4, so we're going to go right here horizontally. All right. 5/6, but I need to have the fractions laid over half and then half the top, half the bottom. That's where I get fourths going horizontally. Now this again, I need to cut it in half. Okay, and then I'm going to do thirds over here, so I need 2 lines to make 3 sections here, and then I'm going to do 2 more lines to make 3 sections on the right. So the total of 6. And I know that I'm creating my, I'll move this up, I'm creating my equivalent fractions. And focus. I don't like it when it doesn't focus properly. It's really annoying. Thank you for listening. 6 times 4 is 24. And so it's like an array that you just created, 4 times 6, or 6 times 4. This one again, 4 times 5 is 20. I have 20 pieces shaded here. You can count them yourself. 1, 2, 3, 4, 5, 5, 10, 15, 20. And then this one, 1, 2, 3, 4, 5, 6. Watch out for counting. Make sure that you have your 6 sections. If you don't make the right number of sections, you won't end up with the right number there. And then 20 minus 6. Oh, and then I also wanted to talk to you guys about common denominators, but we'll do that in a minute. 20 minus 6 is 14 24ths. So this is the watch out for simplest form, because this is not simplest form. So if I have 14 24ths, remember, I have Miss Setness's rules of simplifying. And rule 1 is to look for when a fraction has the number that's doubled on the bottom. So it's like a times 2. Those are always equal to a half. This one is rule 2. Everything that is even is divisible by 2. So I could take this down and simplify the number of parts, and this is still equivalent. 7/12 is equivalent to 14 24ths. I have not changed my answer at all. It just has fewer parts, okay? And so to go back and to look at what could I change it to, or the lowest common denominator, is to take your 6 and your 4, and we went over this briefly on another video, and skip count. And I start with the highest one, and I'm looking for a multiple of the lower number. So this is 6 times 1, but 6 times 2 is 12. And 4 has 4, 8, 12, and voila, I have a common denominator. So really, the lowest common denominator is 12. And how do I get from 6 to 12? I multiply by 2. So 5 times 2 is 10. And how do I get from 4 to 12? I multiply by 3. So 3 times 1 is 3. And when you have 10 minus 3, you get 7/12. And bam, I just did this whole math problem in a simpler way than to have all these pieces. And I still got the right answer, same answer as before. So anyway, that is how to find a lower common denominator. It's hard when we have to use these area models for these, but guess what? We won't be using area models for very long. Okay, 2/3. 2 shaded out of 3 minus 1/7. And so this is always awkward. It's an odd number. 1, 2, 3. I need to be past halfway for 4, 5, 6, 7. Let's pretend those are perfect. And we have, oh, Mrs. Setness, you're doing it vertically. Oh, you know what? I got to get the big eraser for this job. If you guys were in class, you would have been saying, oh, raising your hands all over the place. Okay, there we go. No worries, we fixed it. 7 going this way. 2, 3, 4, a little bit half. 5 and 6, 7, and here is our 1/7, okay? So 7 times 3 is 21. 21, lay your sevenths across this way. 1, 2, 3, 4, 5, 6, 7, and then thirds. 1, 2, 3. I can see clearly. I can see clearly now. I have 3 over here. And then I had 7, and now I have 14. So I have 14 21st minus 3 21st, 13, 12, 11. Don't forget that we're going down, we're not going up, so I end up with 11 21st. And I always am going to think about, can I simplify this? But on this one, I cannot. All right, let's turn the page. A couple more problems on top, then 2 word problems. All right, 3/4 minus 3/8. Notice that they're giving us more shaded pieces on top. That's the numerator. The numerator is on top. Shade your 3/4. And then we have eighths. Now be very careful. I'm going to do it right this time. Half your shape, then make it in fourths. Now cut each one of these fourths in half with a line. And you have even eighths. But I need 3 of them shaded. 1, 2, 3. Now make your equivalent fractions. Now what I want to warn you that this is going to make a lot of pieces. So I'm going to do an alternative model here, just for those of you who are starting to see it, because this is going to come up again. If I have 3/4 here, and that's a little lower than halfway, but that's okay, I will fix it. Well, I'm not going to actually fix it, I'm just going to shade some stuff. Okay, and so we have 3 here. 1, 2, 3. Okay, this is my question to you. This is a statement first. It's not a question. When you look at the denominators, okay, you want to have a number that they both have in common as your lowest common. Oh, there go the lights. Typical. Lowest common. We wanted to get up today, make it exciting. Denominator. The lowest common denominator is going to be the easiest math. So what is the lowest common? Okay, low means it's a low number. Common means that they both have this number as a multiple of each other in common or the same. And the denominator, as you know, is the number that goes on the bottom. So look, 8 is a multiple of 4. It is. So for this one, I'm going to do the lowest common denominator model, and on this one, I'll show you the typical way. Kids sometimes start to get confused here when we use other models other than what the book has shown, but I'm telling you, all we need is the number of pieces. So watch. Now I made eighths on the left and fourths on the right. So how many pieces is that? Good heavens, Mrs. Setness. It is 32 pieces, and it's a lot. Okay, so how many are here? Now this is, when I said, oh, well, you can count them if you want, but 8 times 3 is 24, or you could do 3 times 8. 3 times 8 is 24. Again, do the math. Remember, it's an array. 3 times 8 is 24. Or on this side, I have 4 times 3, which is here, to give me 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have all these different things going on. But what you end up with is 24 minus 12, which is 12. 32nds. And they're both even. That means I'm not done. I have to simplify, and if I don't know a number that goes into both 12 and 32, I would have to start with 2. Another option here, though, is Rule 3, Mrs. Setness's rules for simplifying. Find the greatest number that will evenly divide into both of these. It's called your greatest common factor, and then you can divide both by it. Now, I could divide by 2 halves, but what you'll get is 6/16, and though that's both even again, and then you would have to divide by 2 again, and then you get 3/8. So how can I do this differently? Well, if you have 12 30-seconds and you recognize that 4 would divide evenly into 12 3 times, and 4 would also divide evenly into 32 8 times, you can get to 3/8 in 1 step. Okay? Or you can do 2 steps. You're still going to get there as long as you keep dividing. If you get here and you stop, that would technically not be in simplest form, and then it wouldn't be fully correct. Now, back to this one. Why did she do this, and why are we still on problem E? If 8 is a multiple of 4, okay, 4 times 2 is 8, bam. Then all I need to do is take my fourths and turn it into eighths. If you don't like the way this looks, then turn your model to the same size pieces. And if this makes you happy, look. How many eighths do I have? 6. How many eighths do I have? Well, I didn't have to change that one because it already had eighths. And so now what I've done is I don't have to have 32 pieces to begin with. I have 6/8 that are shaded because I just made my fraction model. And I get 3/8 for my first answer. So, what about that? Huh. Pretty cool. Usually when kids are here, they're like, my mind is blown. It's so cool. Anyway, nobody's here. Just me by myself, and probably the janitor will come in a few minutes. Anyway, let's do another one. Ooh, I'm going to put a hole in my book. 3/4. Oh, that's a little off there. 1, 2, 3, minus 2/7. My book fell on the floor earlier. It just went swoop right off the desk. 1. Oh, that's crazy town. 2, 3, 4, 5, 6, 7, 2/7. 2 are shaded. And again, these don't have anything in common that's really low like 4 and 8 did. So I'm going to have to go ahead and put my 7ths right over the top. 3, 4, 5, 6, 7. And put my 4ths over the top of this one. And know that 28 is my common denominator. And if I had 3/4, but I put 7ths over them, it's 7 times 3 for 21. And this one is going to have 8 pieces because I had only 2 out of 7, and then we've got 4ths going over the top of that. And then 21 minus 8 is 13. And again, that's a weird little prime number there. And so that one cannot be simplified. So we're done with that. Let's hustle. Mr. Penman had 2/3 liter of salt water. He used 1/5, keyword 1/5 of a liter for an experiment. How much salt water does he have left? Let's take our 2/3. Let me put this up top. 2/3 minus 1/5. And we have 2/3, shade, shade, and 5ths, 1, 2, 3, 4, 5, and only one of them. And then lay across 5ths, 2, 3, 4, 5, and lay across 1/3. And 3 times 5 is 15. I've created 15ths. And then to find out how many pieces, brain fart. Anyway, to find out how many pieces, we will multiply 10/15 and 3/15 and 7/15. Some days you just forget what you're doing. Anyway, 7/15 is our final answer, but we also need to label it because it's a word problem. Liter of salt water. All right. There we go. And finally, the last one. I hope you guys could see that the whole time, just in case you couldn't, or I was working off the page. There it is. And then Sandra says that 4/7 minus 1/3 is 3/4 because all you have to do is subtract the numerators and subtract the denominators. And you'd be like, no, you can't do that. Convince Sandra that she is wrong, in a kind way, of course. Sorry that you guys can't read it. It's going to focus very soon. Convince Sandra that she is wrong. You may draw a rectangular fraction model to support your thinking. And so I always like to focus. Teacher problems. There we go. I always like to keep the fraction models going for the first couple lessons, and then after that we just kind of drop them away. Draw your 4/7. Okay, and we'll find out what the real answer is after we've created our fraction models. 7ths, 1, 2, 3, 4, 5, 6, 7, and then thirds. This one's easy. This one's detailed. 1, 2, 3, 4. There we go. And then take your thirds and lay them across here, and take your 7ths and go 1, 2, 3, 4, 5, 6, 7. Let's pretend they're all perfectly even. And when I have 7 times 3, again, that's going to give me 21 pieces in both. And then 3 times 4 will give me 12 for this one. And 7 times 1 will give me 7 for this one. And then 12 minus 7 is 5 21st. And so then the last thing that I want to say about this problem is that we still have to convince her that she's wrong. So if you look at what these mean, 4 out of 7 is about half, okay? It's a little bit greater than half. 1/3 is a little bit less than half. So if I started out with a little more than half and I take a little bit less than half away and I subtract it, I'm going to end up with very little. And so when you look at the size of your answer, I have 5 out of 21 pieces. That makes sense. Okay, so making sense of your answers is a really important part of recognizing if your fractions are good or not. So we'll be thinking and talking about that a lot. Hope this wasn't too long, but I think there was a lot of valuable information in here. If these are helpful, hit subscribe and watch again, and I will be uploading videos. I'll try to get one almost every day, Monday through Thursday, sometimes Friday. You guys have a great day.